An analysis of sales figures indicates that the demand Q for the first brand is modeled by Q of xy, which equals 210 minus 12x squared plus 18y gallons per month, where x and y are the prices of the first and second brands respectively. So this says that the demand for our first brand is going to be dependent on both it and another brand of paint. So both the x and the y. A separate study indicates that t months from now the first brand will cost x is 4 plus 0.18 times t dollars per gallon, and the second brand will cost y, which is 5 plus 0.3 times square root of t dollars per gallon. And we want to know at what rate is the demand Q changing with respect to time 9 months from now. So what we're looking for is Q changing with respect to time, so that's dQ dt, and that's going to be at a time t 9 months from now, so where t is 9. So we'll go ahead and start computing some of these derivatives. So if we want to compute dQ dt, we just need to write out our chain rule. So our chain rule says this is going to be the partial of Q with respect to x, one of its variables, times the dx dt, plus partial of Q with respect to y, its other variable, times dy dt. And so we just need to find each of these partials with respect to Q, each of those derivatives, and start plugging stuff in. So the partial of Q with respect to x, we only have one x term up here. So it's going to be 2 times that negative 12x, so that's negative 24x. The partial of Q with respect to y, we only have one y term, so that's just going to be 18. The dx dt, this is going to be 0.18, so I find my x and derivative with respect to t is just that constant in front of the t, 0.18. And dy dt, if I look at the y function, I have 5 derivative there, 0, plus 0.3 times root t. So again, think that's t to the 1/2, so we get 1/2 of 0.3 times t to the negative 1/2. Or you can rewrite that 0.3 over 2 as 0.15 divided by root t. So either one of those you can rewrite. Now we'll go ahead and plug those into our chain rule. So dq dt is then going to be this partial of Q with respect to x, negative 24x, times the 0.18 dx dt, plus the 18, partial Q with respect to y, times the 0.15 over root t. That was the dy dt. And now we just need to plug in some numbers. So for this particular problem, we were looking at where t is 9. So I can plug in t is 9 right into that root x equation, find out what it's going to be. So x is 4 plus 0.19 times t. T I'll plug in 9, and then just compute that. So 4 plus 0.18 times 9, that gives me 5.62. And then the 5.62, I can go ahead and stick right into my function x right there. Alright, so this is going to be dq dt is negative 24 times the x we just found, 5.62, times 0.18, plus the 18 times 0.15 over the square root of t. And square root of 9 is going to be 3. So I'll just get a 3 right there. Stick all that into your calculator to get a decimal value, and so that's going to give us negative 23.3784. And so this means that the demand for this particular brand, Q, or for our first brand, is going to be going down. Alright, so the demand is going down with respect to time. So as time goes on, we're going to need less and less paint of this first brand. Alright, so that'll do it for the word problems there. In the next section, we're going to look at derivatives in a direction. So besides just in the direction of x and y, so directional derivatives in other directions, and also something called a gradient. And the gradient is going to play a big part in future sections. So that's what you have to look forward to next time.